This is chapter 1.2 in Math 108. Make sure you downloaded the appropriate set of corresponding lecture notes for chapter 1.2. It's located in Blackboard right around where you found this video. If you'll download it, it'll make following along much easier. The very first thing that we're going to talk about is how to graph a function. We have a very basic function here. So we're going to graph y equals x squared. So you should have a similar graph on your paper. Essentially what we need to do is we need to choose some x values and then find the corresponding y values, while also trying to ensure that we capture the entire graph. So the x values I'm going to choose are -2, -1, 0, 1, 2, and I'm going to choose 3 because I believe you have 6 slots available as I do. Alright, so if I plug -2 in for x, so y equals -2 squared, -2 squared is 4. So my corresponding y value is 4. If I plug -1 in for y, or for x, my y here, -1 squared is 1. So my corresponding y value is 1. If I plug 0 in for x and find my y equals 0 squared is simply 0. So my corresponding y is a 0. If I plug in 1 squared is 1. So my answer is simply 1. If I plug in 2 squared is simply 4. And if I plug in 3 squared is simply 9. So if I go about plotting this graph, I go to -2 on my x-axis. Remember, this is your x-axis, this is your y-axis. I go to -2 on my x-axis, and I go up to 4 on my y-axis. I go to -1 on my x-axis, and I go to 1 on my y-axis. I draw a point at 0, 0, a point at 1, 1, a point at 2, 4, and I'm going to draw that point at 3, 9 as well. You should notice that if I had gone to -3, I would have also gotten a 9. Now if I connect these dots, and create my graph with them, it should look something like that. This is the complete graph of y equals x squared. Now what I'll show you next is how to perform this on your TI-84 calculator. So what we'll do is I'll show you how to input the function on your 84 calculator. I'll show you several different ways that you can find the table set up on the calculator, how you can trace the function, and how you can ensure that you actually have the entire graph of the function, the zoom functions and such, so that we can make sure that we get a full picture of the graph we're hoping for. Alright, so what we're going to do here is I'm going to show you how to work the TI-84 calculator. So, hopefully you can see. So, here, if we start with the very blank screen that you're probably going to see, the first thing that we're going to do if we want to graph this y equals x squared on the TI is hit my y equals button. The next thing we're going to do is we're going to type in this x squared. So we're going to do x raised to the second. And I'm going to hit enter. And then if I want to see the graph function, I'm going to hit graph. Now, as you can see, the graph shows up on my graph. I have a standard zoom. If your zoom is not in standard, you need to hit zoom and go down to number 6, zoom standard, and it will zoom standard for you. Now if I needed to fill this table out and I didn't want to do it by hand, I would go second table, and the list of values I have here could be the list of values that I put in the table. So -2 for my x, -1, 0, 1, 2, 3, just like we found on the board. We'll give you a 4, a 1, a 0, 1, 4, and a 9, and you have many other values you can see as well. Now, just a review, if you've never used the TI-84 before, little intro. Zoom, You have several different ways you can zoom. If you want to zoom in, you can use the zoom in button. Zoom out, you can use the zoom out button. Standard is the one that's rarely used a lot for things that are in that 10 by 10 window. Stat is used anytime we decide to plot a bunch of data points. It works very well. And zoom fit normally works decent. Sometimes with zoom fit you'll have to do some adjustments. But zoom fit generally at least gets a piece, if not most of the graph, into the actual window. Now if we look at this second page of your lecture notes, the next question says the number of U.S. adults with diabetes in thousands projected to 2050 is shown in table 1.12, and you see the table there. So you have your years 2015, 2020, 2025 on up to 2050. And then you have the thousands of people represented. Now part A says align the data so that X equals the number of years after 2015 and enter these X values into L1 of your graphing calculator. Enter the number of millions of US adults with diabetes into L2. Okay, so what we're going to do here is we're going to use this table and we are going to put it into our graphing calculator. Now we have to align this table correctly, and this is where it can get just a little tricky. So if we're looking at this, it says that X is the number of years after 2015. That means that the year 2015 represents year 0. 2020 represents year 5, 2025 year 10, 15, 20, 25, 30, and 35. Now, that's not the only thing that we have to align in this problem. According to the information that we have, the number on the right hand side is projected in thousands. So if we want to enter the number of millions of US adults into L2, we need to convert thousands into millions. In order to do that, 37,300 thousands would be the same as 37.3 million. This would be 50 million, this would be 59.5 million, 68.3 million, 76.2 million, 84.1 million, 91.7 million, and this would be 100 million. So these are represented in millions. Now, let's look at how we enter this into on the calculator. So if I have my calculator here, what I'm going to do, I'm going to hit the button Stat. Then I'm going to go to Edit, and if I already have a list in there, I'm going to clear it out. Now L1, it asks to be your X variable, so the years. So I'm going to start with 0, 5, 10, 15, 20, 25, 30, 35, and then in my L2 I'm going to let that represent the millions. So 37.3, 50, 59.5, 68.3. Make sure you'll have to double check yourself. Sometimes if you hit a button on these TIs, it doesn't necessarily go in. The button may stick, or you might not hit the button hard enough. It's always good to double check your data sets. Now, once I have that entered, what we want to do is we want to create a scatter plot of this data. In order to do this, what we're going to do is we're going to go second stat plot. Now, this plot number 1 is turned off. We're going to turn it on. We're going to make sure that this type here with the dots is highlighted. If it isn't highlighted, go over to it, select it, and hit enter. Make sure your X list is your L1, your Y list is your L2. You can change the marks of your data if you like, but that really doesn't matter in this situation to us. If you hit the graph button, you're going to notice you're still going to see that Y equals X squared function. We need to go and clear that out. The next thing we need to do is hit the zoom button, and we need to go zoom stat. By going zoom stat, it presents your graph with this data that you've inputted, and it graphs it where you can all see it. So this is what we've done. We've entered our data into the edit list underneath stat. We've gone to second stat plot and turned our stat plot on. We've made sure that our stat plot for our points is highlighted. We've gone to zoom and hit 9 for zoom stat, and it's plotted this entire list for us. If you can do this on the calculator, you are well caught up with what we're doing now. On page 3 of your lecture notes, you'll see you have 2 examples, and it says make a table of values for each function, then plot the points to graph the function by hand. Now, we can find these values by hand, but in this class you have complete and total access to the TI-84. So what we are going to do is we're going to turn our stat plot back off. An easy shortcut method to doing that is hitting Y. If you're on your blank screen, hit Y equals. This stat plot is probably highlighted from where we had it on. If you unhighlight it, it turns it off. Now, I'm going to enter this function, 1/2 x squared, into my Y equals. And then if I want to, what I'm going to do is I'm going to hit zoom standard, because we have a standard graph here, so I assume it's going to line up nicely with the standard graph. So zoom standard is number 6, and it's going to graph this for me. It's a simple parabola. Now, if I want the table values that go in here, I'm obviously going to need some left of the 0, 0 origin and some of right of the origin. So I'm going to go second table, and I'm going to grab some points that are going to be to the left of the origin and to the right of the origin. So one point I can grab is -4, 8. I can also grab -2, 2. If you notice, the origin 0, 0 is actually a point as well. 2, 2 is a point. 4, 8 is a point. And if you wanted to, you could do 6, 18, but it's not going to fit on this particular graph. Honestly, in this scenario, these 5 points will do an excellent job of representing this data. This 6, 18 could just be extra if you have the space to graph it. Now, I'm going to go back to my graph to make sure I know what it looks like. It's simple in this case, but in other cases it may not be. So I'm going to go to -4, and I'm going to go up 8. So -4 up 8, and I'm going to place me a point. Then I'm going to go to -2 up 2, place me a point. 0, 0, place me another point. 2, 2, and I'm going to go to 4 and up to 8. Now, what I'm going to do is connect my dots as best I can. Try to make it look as close to the TI-84 as possible. A nice parabola, all with the correct points. Now for the second graph, I'm going to go back to my Y equals and clear it out. I'm going to hit X divided by, here's where you have to be careful. There's an X plus 3 in the denominator, so I'm going to put that in parentheses. So X plus 3 in parentheses in the denominator, so that the entire X plus 3 is taken into account in the denominator. If you do not put that parentheses, the calculator will not read it correctly. Now, I'm going to hit graph. If you notice, I actually have 2 curves here. I have a curve that goes up, and then I have a curve that plateaus out here. Now, the reason that is, if you refer back to what we did in the domain in chapter 1.1, I have a discontinuity at -3. Reason being is I cannot have a 0 in my denominator. If X is -3, I have a 0 in my denominator. Therefore, my graph cannot touch that point. So, what happens, as you can see with your TI-84, is I have a graph going up close to that -3 point but never touching, and then after I'm past that point, it gets close to it as well and then comes back up and around. We need to make sure that we can represent this when we graph it by hand as well. This is why I suggest graphing it on your TI first, to make sure that you're getting both sides or all sides of the potential graph. If you just graphed this by hand and went from -2 to 3 like we did in that very first graph of this chapter or this lesson, you wouldn't have captured this secondary curve. Now, I'm going to go to second table. As you noticed, at -3 we have an error. Once again, that's because we can't have a -3 in this denominator, because it would make our denominator 0. So I'm going to grab a few points over here on the left hand side. Looks like I've got a x equals -6 and a y equals 2, and I have an x equals -4 and a y equals 4. Let's see, maybe I can grab another point. Maybe it's always good to write these in order. So if I adjust accordingly, let's do -9, 1.5. We'll rewrite that -6 and that 2. We'll do -4 and 4. And then we'll grab some on the other side of that -3. So I've got a -2 and a 2. I've got a 0 and a 0. And we need one more good one. Let's see. We don't get any good solid ones here. Let's do a 3 and a 0.5. Now let's graph those points. So if I go to -9 and then I go up 1.5, it's going to be approximately right there. -6 and then up 2, it's going to be approximately right there. -4 and up 4, 1, 2, 3, and 4, it's going to be about right there. Now if I plot -2 and then go up 2, 1, 2, I go to 0, 0, and I go to 3, 1, 2, 3 and a half. Let's go back to graph. What we notice is that I did something wrong. Second table. This -2 is supposed to be a -2 here. I just mistranscribed. You have to be really careful with that. -2, -2. It's very easy to mess these up if you're not being careful. It always pays to double check yourself. So, if I want to go back to graph and make this graph look the same, I have to remember that it never touches this -3, so it approaches it, but it never touches it. I will draw my curve to look as best as it can, and I will draw this curve to where it also approaches this value here, and it goes down here. So it looks approximately the same. This is why it's important, if you can use your TI to graph it first, be really careful about the points that you do imprint, because just as I screwed up the -2 for your y here by just leaving off a negative, it can really mess up your graph. That's why it pays to always double and even sometimes triple check with your TI calculator. That point didn't make any sense. We knew we had done an error and they needed to put it down here because we had just mistranscribed. But if you have your TI, you can catch yourself on simple things like that. Now the next thing we see here on page 4, it says graph the functions with the graphing calculator using a standard viewing window. State whether the graph has a turning point in this window. So if I go back to y equals, let's simply graph this first graph. X raised to the third minus 3x squared plus 4. Now if you notice what happens here, if you're not careful, it plots all of that in the exponent range. That's incorrect. What we need to do is we need to hit x up 3, and we have to make sure that we actually get out of the exponent. The easiest way to do that, I'll show you again, x up 3 is hit right. If you hit to the right one time, it gets you out of the exponent range. Then we're going to hit minus 3x squared and then plus 4. Now we have the proper equation in our y equals. Now we want to graph it, it says on the standard viewing window. So if we do standard viewing window, I'll hit zoom standard, and the calculator will graph it for us. Now it says state whether the graph has a turning point in this window. Now, a turning point is simply where the graph turns. It's usually called a min or a max if you're talking specifically about each. So this graph, it comes up and it makes a turn here, and it also makes another turn there. So it comes up, it turns and goes down, and then from going down it turns and goes back up. So yes, this graph has a turning point on that window. It actually has two turning points. Okay. Now, if I wanted to, I could use my calculator to find exactly what those turning points are. To do that, I would hit second calc maximum to find this maximum point. I would simply go left of it, hit enter, go right of it, hit enter, and then guess and hit enter again. The point I get is a 1.46 e to the negative 6 and y equals 4. Now when you get a weird return like this, it essentially means that x equals 0, y equals 4, as you can kind of tell from looking at the graph. So my maximum point here, my maximum turning point here is 0, 4. Now if I wanted to find my minimum turning point, I would second calculate minimum and do the same thing. I would be left of it, hit enter, right of it, hit enter, guess, hit enter again, and I get the minimum is x equals 1.99999 and y equals 1.3 e to the negative 11. Now you might get something a little different depending on which brand and style calculator you have, but essentially what this means is x equals 2, y equals 0. Now let's look at the second function. Y equals 40 divided by x squared plus 4. So y equals 40 divided by, this is another case where you have to be careful. We want to make sure this x squared plus 4 is all considered on the bottom. So I'm going to put it in parentheses. So x squared plus 4. And close my parentheses. Now I'm going to graph that on that standard window as well. And if you notice, it goes up and then it comes back down. So I have one turning point. So yes, I have one turning point on this graph. That turning point happens to be a maximum. And once again, if you wanted to find it, you can do second calc maximum. Go left bound, go right bound, guess about where it's at. As long as you get close, the calculator will find it. So the turning point that I have here is x equals 0, y equals 10. Number 5 says, graph the given function with a graphing calculator using the standard viewing window and the specified viewing window. Which window gives a better view of the graph of the function? Now, y equals negative, make sure you hit the negative and not the minus, negative x squared plus 20x minus 20. And it says that we need to graph it on the window negative 10 to 20, and on the y, negative 20 to 90. Now if we graph it like that, what we see here is that we have a maximum. Okay, so we see that we have at least one turning point here, and it is a maximum. If instead we had graphed it on the standard viewing window, so zoom standard, what you notice is that all we see is an almost straight line. So we wouldn't have known we had a turning point on this graph. So which window gives a better view of the graph of the function? The specified window. Or you can write the window negative 10 to 20 and by negative 20 to 90. So this is the window that works best. Number 6 says complete the table. Now, if you want to, the easiest way to complete this table is using your TI. So I have 5.2x minus 10.5. Okay, I can hit second table and I can scroll to all these values. So I can scroll to 12 and see that my return here is supposed to be 51.9. I can scroll to 16 and I can see that it's supposed to be 72.7. Now, 28 and 43 You can still scroll to those. It's quite a bit of scrolling. If you wanted to, you could graph the information, the data. What you notice is you do get to see the information here. However, 28 is not within this range. If you're wanting to graph and find what 28 and 43 are, they have to be within the window. So I'm going to adjust my window so that my X max is 50. I'm going to hit graph. Now you notice I still can't see the graph at those points. So in this case, what I'm going to do is I'm going to hit zoom, fit. And what it'll do is it'll maintain my X window, but it'll stretch my Y window accordingly. So if you look at your window, my X window stayed negative 10 to 50, but my Y window was the one that was actually shifted so that I could see the entire graph. At this point, all I have to do is hit second calc, value. My X value that I'm calculating here is 28, and it tells me that my Y value in turn will be 135.1. Now if I do this for 43, so second calc, value 43, hit enter, I get 213.1. So instead of having to scroll all the way through your table, you could use that method as well. Or, as always, you could solve it by hand by placing these values in for t, whichever you would prefer. Number 7 says data for selected years from 2011 and projected to 2023 can be used to show that the balance of federal direct student loans Y in billions of dollars is related to the number of years after 2010 x by the function y equals 130.7 x plus 699.7. Now A says graph the function for x values corresponding to 2010 to 2025. Okay, so if we notice and we go back and read our question, it says is related to the number of years after 2010. That means that 2010 is going to be year 0. 2025 is going to be year 15. So, with that being noted, if I wanted to graph this, I would hit y equals, clear this out, it'll be 130.7 x plus 699.7. Now, I want to graph it for these years. So what I'm going to do is go to my window. I'm going to go 0 to 15. I'm going to hit graph. It's probably not going to do a great job on my y-axis of graphing this. So what I'm going to do next is go zoom, and then I'm going to go fit, and it'll adjust my y-axis accordingly so that I can see my graph. So you can see I've got my line here. I've got my x-axis here. If you want to double check that your x-axis didn't move on your window, you can. 0 to 15. And here's my y. Okay, so we've graphed it with these corresponding values. Now we need to find the value of y when x is 13. We can simply hit second calc, value, x is 13, enter. The y that we should get is 2,398.8. Easy as that. C says, what does this function predict the balance of federal direct student loans to be in 2029? Well, we have to adjust 2029 to see what x value we actually plug in. So if we do 2029, okay, so 2029 minus 2010, we get an x value that we're supposed to use of 19. If I plug this 19 into this equation, I can find this. Or I can simply go second table and scroll down to 19 and find it as well. You can also do it by second calc on the actual graph. The number that I get is 3,183. Now this is where we have to be careful. It says y is in billions of dollars, so we definitely want to write our unit here. 3,183 billions of dollars. This concludes the Chapter 1.2 lesson. Please go online and complete the homework associated with Chapter 1.2. After you've done that, please download Chapter 1.3 lesson notes and begin to watch the Chapter 1.3 lecture. If you have any questions with Chapter 1.2 lecture or homework, please email me and let me know. Other than that, thank you for watching.